Inkling, this is the first open weight model released from Thinking Machine, and it's a big deal. Now, to tell you why, it's open weight under Apache 2.0. It's trained from scratch, so they're not reusing any existing architecture. Apart from NVIDIA, this is going to be the biggest model release from a Western lab by far. And it's built multimodal from the ground up. Now, so far, when it comes to model releases, you can just divide them into two different parts. Western labs have mostly released frontier level closed source models. For open models, we have mainly relied on Chinese companies, but most of them are text first. But when it comes to frontier level open weight model from Western labs, it has been pretty empty so far. But with this release, things are changing. And the best part is that it's multimodal in nature. So they have trained it with text, image, and audio input. Now, the model itself is genuinely good. I'll show you some outputs later in the video. But first, we need to talk about the architecture. It's almost a trillion parameter model, 1 million context window, and it's trained on 45 trillion tokens of a mixed multimodal data. Now, this is a mixture of expert, or MOE. There are 256 experts in total with 2 shared experts. There are 6 experts per token that you see. And as a result, you're going to have 41 billion active parameters. So it's a relatively sparse model. Now, if you look at the benchmarks, it's actually not state of the art on most of them. However, it's a well-rounded journalist. And this is a big achievement from Thinking Machine because this is their first open weight model release. So you need to give them credit for what they have achieved here. Now, in terms of products, this is their third release. The first one was Tinker, which is an API product for post-training your models. Now, after that, they recently showcased their interaction models, although they are not publicly available. But the beauty is you can use Tinker to actually fine-tune this model. Now, apart from this, I think the most important and interesting one is going to be Inkling Small, which is a smaller 276 billion parameter model with 12 billion active parameters, which is going to be, I think, much better to run on consumer hardware. But we will have to see when this is available. Now, this model is available on the Tinker platform, which means you can fine-tune this on your own data by renting compute from Thinking Machines. Just bring in your data, you have the free base model available, and you will be able to further post-train and fine-tune it, especially if you have multimodal data. This is a decoder-only model, and it's actually really strong when it comes to multimodality. This is one of the places where it actually beats most of the open weight models on key benchmarks. It seems like this is powering the interaction models that were recently announced by Thinking Machines. Now, right now, self-evolution is a big, hot area. So in one of the studies, they asked the model itself to fine-tune itself using the Tinker framework. And right now it's using the open code harness to actually fine-tune itself, which is kind of incredible. Now, in terms of benchmarks, this seems to be extremely strong on design. If you look at the design arena leaderboard, this is just behind the state-of-the-art frontier models and GLM 5.2, which I think is a really big deal, especially this is the first open weight model released from Thinking Machines. Now, when it comes to actual design, you kind of see a template or pattern that it follows. I'll show you a couple of examples later in the video. Okay, one last technical detail before we look at some of the demos. Now, it's a reasoning model, so the thinking effort plays a critical role when it comes to the performance of this model. And you will have to adjust it based on your needs, because that is going to really determine the quality of output. Okay, so if you want to try this model, you can download the weights if you have enough compute to run a trillion parameter model, but you can try it for free on their playground. A link to that is going to be in the video description. I really like the way they keep changing these hero messages. They are pretty nice. So before we start testing the model, a few things to notice. So on the left-hand side, you're going to see the reasoning effort. You can set it on none all the way up to extra high. Then you have maximum number of tokens. At the moment, I think it's limited to 256K and 64K. They don't expose the full 1 million token through the playground. And then you can enable or disable web search. But there's another interesting thing here, and that is the system prompt, which you definitely want to have a look. So the system prompt really gives you a sense of what the prompt template looks like. The cutoff date is April 26, which is really recent for training a model of this size. Then they limit the context window to 256,000 tokens. And then there's a section on the different capabilities that are available. Although it highlights multimodal, they haven't enabled image, audio, and video. And then it tells the model how it's going to cite and sources if the user asks it to. Right? So a relatively simple system prompt, but if you want to use it through the API, you need to follow this format. Okay, the model itself is extremely fast. So we can say something like, the thinking machine just released Inkling. This is their newest open weight model. Do web search, find me all the information that you can, and then create a minimalist but highly detailed and aesthetically pleasing website to render all that information in the form of a website. Okay, so I'm actually happy with the transcription. By the way, if you're interested in how I do the transcription, this is my own app that I'm building. It's called Write, and it's one of the fastest, completely local and private speech transcription system available for Mac OS at the moment. Okay, so a few things. Since it's an open weight model, it actually gives you its reasoning traces. Second, it can do interleaved function calling or tool calling. So right now it has access to the web search tool, and you can see that the queries that it generates for web search, and then the actual results that it's getting, right? So you actually see all of the operations that it's doing. So again, thinking through its steps, and the thinking is extremely coherent and extremely detailed. Now the thinking is done, and right now it's doing the actual generation, which is again really fast. Now, I don't have any information on the actual number of tokens, but for a model of this size, this is pretty fast. Okay, so this is the version that it just created. So you actually have information about when this was released. We can click on the architecture. Shows that it's an MOE, although I think it could use some work. Capabilities, text, image, audio, and the ability to control the reasoning. Then it has information on the training data, plus the training recipe, in what type of hardware it was used. It also figured out the benchmarks, right? So pretty detailed. However, there's one interesting thing about the websites that it creates. Here's a previous run for the same prompt, and you can see a lot of similarity between this website and the one that we just saw. So it will create websites in this specific design if you don't tell it a specific design template that you want it to follow. So for example, I wanted to see how good this is at web design, so I provided a really detailed prompt. Now I wanted it to create the website for my product, and it did, I think, a decent job. It follows the prompt pretty accurately. This is pretty decent coming out of a large language model. However, as a follow-up, I simply asked it to take the creative freedom and redesign this website. And as expected, it basically redesigned it exactly in the same style that we saw before for the other websites, right? So this seems to be the default pattern that it wants to design web pages in. And I would say it definitely needs some work in terms of taste. Now, when it comes to coding, this is not state of the art, but still it's a very reasonable and capable model. So for example, in this case, I asked it to create a real-time tracker for ISS. We provided the API endpoint. But keep in mind, it's just generating everything in chat. Okay, it still does a pretty good job. So right now, it's showing that it's just off of the coast of South America. And we can actually see right now Here's the location. It's off by a little bit, but the approximate location is correct. Okay, so the last thing I want to look at is the pricing of the model, because this is going to be important if you want to use this model on their platform. So there are two different pricing structures depending on how many tokens you're going to use. If you have 64,000 tokens, 1.8 cents, 87 cents input, almost $4.7 output. So I think it's not the most affordable model. It's on the more expensive side. However, since this is an open weight model, you can download it and you can run it on your own hardware. But if you're using Tinker, you can also fine tune and train this model at affordable cost. Now, personally, I'm actually excited because we have yet another option when it comes to Frontier Labs. And as I said, this is just the first iteration of the model. The next ones hopefully are going to be much more stronger, especially if they're going to be multimodal. Do let me know what your experience with this model is. What are the strengths and weaknesses that you're noticing? Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.